Hello students, welcome to Math at Ease, where I try to make math easy for you. And today's topic for our video is conversion of decimals to rational number. Okay, this is a very important topic, and without wasting much time, let me quickly move on to my green board. So students, you should be aware of one thing, that decimals are of total three types. They can be terminating, they can be non-terminating repeating, or they can be non-terminating non-repeating. Okay. Now only the first two categories can be converted to rational number form, because the third category, which is non-terminating non-repeating, is not considered a rational number because it's not possible to convert to P over Q form. So first of all, before we start taking terminating decimals, we'll take examples from terminating decimals. Okay. Terminating is very easy. You don't need much explanation for this. Rational number means I need to put it in the form of P over Q, and always try to write your final answer in the simplest form. Okay. So let me quickly take one or two examples. Let me say 2.57. How do I convert it to terminating decimal? I can multiply numerator and denominator with 100, because there are two decimal places. We multiply with 100. So that will give me 257 over 100. Is that in the simplest form? It seems like. Okay. I'm not going into the detail of that particular thing. Let me take a second example. Say 5.4. Okay. Here if you see, there is only one decimal place. So you will multiply numerator and denominator with 10 so that the decimal point moves. This is what you get. You can always bring it to the simplest form, which will be 27 over 5. Okay. Or the other way is writing it as a whole mixed fraction, 5 whole 2 over 5. That's it. So it's already converted to rational number form. So this is not the difficult part. Now the difficult part is converting non-terminating but repeating decimal to rational number. So I'll take up that non-terminating repeating decimal. Okay. To P over Q form. Now there are three types I can take it up. First of all, a simple example that I'll take is, say 0.7777 dot dot dot. Okay. Now what you have to check, step 1 is, since rational numbers are denoted by Q, let my Q or let my number be 0.777 dot dot dot. Okay. Now, how many digits are repeating here? If you see, there is only one digit 7 which is repeating again and again. So what we try to do is, first of all, I'll number this as my equation 1. Okay. Since there is only one digit repeating, I multiply both my sides with 10. Okay. Then what will happen? I will get 10n is equal to, now if you see, if you multiply this with 10, the decimal point will shift that side. So I will get it as 7.777 and so on. See, there are all sevens. Okay. Let this be my equation 2. Now what you have got two equations where the decimal part is exactly the same. Okay. So my step 3 is to subtract my 1 from my 2. Okay. And if I subtract, what do I get? 9n is equal to 7.0. Why? Because the decimal part is exactly the same, so it gets removed completely, and that is our main idea. Okay, so that my n is equal to 7 over 9. That's it. So the decimal 0.7777 is nothing but the rational number 7 over 9. You can actually do the division or use a calculator to check if your answer is correct or not. Okay. Now, let me move on to a second example. Example 2. Okay. Here, let me take the decimal, say 5.237 bar. Okay. Now here I have represented the same decimal in a different format. What does the bar indicate? It indicates that that particular block of digits is repeated. So we follow the same steps. Step 1, let n be 5.237237 dot. Okay. Here, what should you multiply with? There are three digits totally repeating, 2, 3 and 7. So, I should multiply my n with 1000. Okay. So, my step 2 becomes 1000 n is equal to, what will happen if I multiply this with 1000? The decimal shifts to 1, 2 and 3, so that one full block is moved to the left hand side. So I get 5237.237. Students, at any point of time, your idea should be to bring one whole block to the left hand side. You cannot break the block. That was the reason why I multiplied the decimal with 1000 and not with a 10 or 100. Okay, because if I multiply with 10 or 100, I will not get my second number with exactly the same decimal part. Okay, here if you see, this number is also having the same decimal part as the previous one. So my step 3 will be to subtract my original one from this, put the numbers properly below and then subtract, so that you'll get 999n is equal to, the decimal part becomes 0, 7 minus 5 is 2, 3, 2, 5. So that n becomes 5232 over 999. I stop here. You can bring that to the simplest form. Always try to. Okay. And now let me take up one more example, which is the most difficult one, but the concept remains the same. Now students, if you see this particular example, it looks little complicated, but it's not at all difficult. Okay. What is the difference between this example and the previous ones? Here if you see, the bar is over 1 and 3 only. Okay. And you have the digit 2 in the decimal part, which is not going to be repeated. Okay. So here we have an additional step. So first, anyway, we start with our step 1, where I write my n as 15.213. Okay. Now here our first step should be to bring the 2, which is the non-repeating part, to the left hand side. And if you can use a little bit of math, you can do that by multiplying n with 10. Okay. So my step 2 will be, I multiply both the sides with 10 to get 152.13 bar. Now can I do the subtraction like in the previous cases? No, because there is the decimal part of this is different from the decimal part of this, and if I try to do the subtraction, I will still end up getting a non-repeating decimal part, okay, which is not what I want. So what I can do is, I can multiply now this with another suitable number, okay, where the pattern, the decimal part is exactly the same. So what can I do? Now I can clearly see the two digits are repeating. So what I can do is I can multiply both the sides again with 100. So I'm multiplying both the sides of 10n with 100. So that becomes my step 3. So if I multiply this with 100, I will get 1000n is equal to 15213.13 bar. Okay, and now if you can see, the equation number 2 and 3 have the same decimal part. Okay, so now I can follow the same step as before. I just subtract. So I subtract 2 from 3. So let me change the color. So minus 10n, put the decimals properly below 0.13. Now if you see, they both have the same decimal part, so the decimal part is removed, and on the left hand side I get a 990n. Okay, and here I get 3 minus 2 1, 11 minus 5 is 6, and 0 5 1. Okay, and that is nothing but n is equal to 15061 over 990. So see, whatever is the type of decimal, if it is terminating or non-terminating but repeating, you can always convert it into the P over Q form. Okay, hope it's clear to you. If you want to have some other topics that I want to take up, please mention in the comment section. And don't forget to subscribe my channel and like my video.